For many people, programming can already be a pretty complex and frustrating task. Keeping track of everything your program does internally, trying to trace bugs, all while dealing with the unique quirks and syntax of a language, can drive people to insanity. And as a result of that, the creators of most programming languages try to alleviate at least one of those issues while creating their language. Languages like Python use a pretty simple syntax, and they use a data type system that's fairly easy for new users to grasp. Languages like Rust emphasize memory safety, and languages like C++ and Lisp fix all these problems by getting people to give up on programming in the first place. But what if instead of alleviating these issues, somebody decided to intentionally make a language that, while functional, managed to take every aspect of programming and make it 1,000 times more difficult, to the point where nobody would want to use this language for any practical purpose? Well, that's where esoteric programming languages come in. ESO-langs are programming languages designed specifically to push the boundaries of programming language design, usually in some humorous fashion. Today we'll go over some of the more notable ESO-langs, and talk about how they work, how they compare to more traditional programming languages, and even talk about some of their histories, which can get a little crazy. And even if you don't program, I guarantee you'll at least want to learn about the last one on this list, because the story behind it is one of the craziest things I have ever read. Now with that behind us, let's jump right in, starting with the very beginning. INTERCAL is considered to be the first esoteric programming language, and the name INTERCAL is actually an acronym. It stands for the compiler language with no pronounceable acronym. No, I'm not kidding. This archived site for an implementation of INTERCAL called CLC INTERCAL has this to say about the language. INTERCAL is a computer language which you really do not want to use if you have any sanity left. And if you want an example of how little sense this language makes, the first 2 paragraphs on this page are a valid INTERCAL program. At least that's what the authors of this page claim, and why would anybody lie on the internet? Designed in 1972 by Jim Lyons and Don Woods, 2 students at Princeton, INTERCAL was meant to be a parody of parts of popular programming languages at the time, such as Fortran, COBOL, and assembly languages. Since it was conceived before personal computers began to take off, the first implementation used punch cards, which happened to use EBCDIC, which was a completely different character set than the ASCII character set that most computers would adopt soon afterwards. This meant that later implementations had to make some changes to the characters used. And if you're wondering why they chose the question mark for the exclusive OR operator, the INTERCAL reference manual says that it was chosen to correctly express the average person's reaction on first encountering exclusive OR. Truly impossible to make up. So let's give it a go by writing a Hello World program. If you're out of the loop, a Hello World program is a basic computer program that's mainly used to show a user how the basic structure and syntax of a language work. And all it does is write Hello World to the console. For example, this is how one might write a Hello World program in the C language. You have the main function where everything runs, and then you have printf, which just prints whatever's in the parentheses. And I want you to keep this program in mind as a benchmark of what a typical programming language might look like. Now let's take a look at a Hello World program in INTERCAL, and yep, that sure looks like nonsense. If you're curious about how this program even works, you can read this, but something you might have noticed are these please tokens that are kind of sprinkled throughout the program. Well, the placement of these tokens doesn't actually matter. You can place them on whatever line you want. But for a program of this length, you're going to need about 4 or 5 of those. Because if you have only 3 or less, then you'll get an error saying programmer is insufficiently polite. And if you have 6 or more, then you'll get an error saying programmer is overly polite. Now comparing this to a C program, I'm sure you can see why this language is basically never used. However, looking at these errors and the general attitude around the project, you can actually see the beginnings of a joke. This actually led the Nobel Prize Committee to recognize Lyon and Woods as the first ever programmers to be funny, and now every programmer that attempts to make a joke owes these two their very lives. Now if you've gone through 8th grade English, you've already read your first Shakespeare program. Romeo and Juliet, Hamlet, Macbeth, all famous in the programming community for the massive leaps forward they made. Now if you don't come from a primarily English-speaking country, don't worry, I'll run through how this programming language works. Basically, the syntax is modeled on plays written by this random guy that nobody's ever heard of. Don't worry about it. So let's take a look at a typical Shakespeare program. This is a Hello World program in Shakespeare. You can see that the program is split into acts and scenes, and these serve as go-to labels which your program can jump to via statements such as, "If so, let us proceed to scene 2." You can declare a variable by naming it in the dramatis personae, and please note that you can only name variables with names held by actual Shakespeare characters. You can then bring a variable into the scope by calling a character to the stage. You can see it here with Enter Hamlet and Romeo. You can make a character exit the scene with exit character or multiple with exeunt. These variables or characters talk to each other through lines, not like those lines, but lines as in dialogue, script. Not like that script. These lines are used to call procedures or assign values to each other. If you wanted to assign a value to a variable, you would have one variable say align with this general structure. UR as adjective as mathematical formula. Constants in this language are represented by a combination of adjectives and nouns. Adjectives and nouns are categorized into positive, negative, and neutral tone. Adjectives multiply nouns by 2, positive and neutral nouns have values of 1, and negative nouns have a value of -1. There's also basic operations like sum, quotient, and cube. So if, for example, you wanted to assign a value to Ophelia that was 10 more than the square root of Tybalt, you could have Mercutio say, "You are as stupid as the sum of the square root of Tybalt and the sum of a sweet, peaceful, brave hero and a clear sky." A sweet, peaceful, brave hero would evaluate to 8, and a clear sky would evaluate to 2. The sum of these would evaluate to 10. So if Tybalt held the value 81, then the square root of him would be 9, and 9 plus 10 of course evaluates to 21. Shakespeare also provides some I/O through the characters' hearts and minds. Open your heart will output the variable's numeric value, and speak your mind will output the ASCII character that the number contained in the variable corresponds to. Sorry Unicode bros, today's just not your day. Listen to your heart and open your mind, take numeric and ASCII input respectively. Shakespeare was designed in 2001 by geniuses Jon Asland and Carl Hasselström for an assignment in their syntax analysis course, late at night, when they were supposed to be doing another assignment that was due the next day at 9 in the morning. This isn't a joke, and these guys are now my new heroes. And I am truly sorry, Carl or Kala. I know you're not gonna see this, but I truly have no idea what your name really is. On Wikipedia, it calls you Carl Viberg. On your SourceForge title, it calls you Carl Hasselström. The introduction to the same SourceForge article calls you Kala Hasselström, so I really don't know. I just used the name from the title. If anybody knows for sure, leave a comment or something. Chef is a programming language that is supposed to make your program look like a cooking recipe. It's a stack-based language, which means that it works primarily by pushing and popping values on and off the top of a stack. A typical chef program or recipe looks like this, with a list of variables or ingredients along with their values listed at the top, and then a list of instructions listed under the method. And then here at the bottom is the serving size, which prints out the values on the stack or dish until all the values are gone, and then moves on to the next dish. The chef design document lays out a couple of strict but fair design principles, which read as follows. 1. Program recipes should not only generate valid output, but be easy to prepare and delicious. 2. Recipes may appeal to cooks with different budgets. And 3. Recipes will be metric, but may use traditional cooking measures such as cups and tablespoons. Chef was created in 2003, I think, by David Morgan Marr, aka Danger Mouse, who is an Australian webcomic artist, a programmer, a regular magazine contributor, and published physicist with multiple patents. He's also the creator of other SO-langs, such as Ook, and the next language we'll be covering. Piet is a language designed by Morgan Marr to look like the abstract art done by Dutch painter Piet Mondrian. He was actually going to name it Mondrian, but the name was already taken by, quote, a rather mundane-looking scripting language. Piet programs are bitmaps comprised of 20 different colors, 18, quote, colorful colors, and then black and white. The 18 colorful colors are divided into 6 different hues and 3 different brightnesses. Program execution is based on a pointer that moves around the image, and when the pointer moves from one colorful color to another, it performs a procedure which is determined by the number of steps the pointer makes with change in lightness and hue. White doesn't perform operations, and black cannot be entered by the pointer. You can find a variety of Piet interpreters online, and even other versions of the language. Piet++ is like Piet, except it provides access to multiple stacks, adds more operators, and it has even more colors, so now you're even more confused when looking at it. This is of course another example of languages ending in ++ being more confusing than their predecessor. There's also
Piet,
which is simply a text-based version of Piet that uses Unicode emojis instead of Piet's codals, which is genuinely just a good idea. LOLCODE is a language based on the best internet meme of all time, LOLspeak. It was created in 2007 by the exact kind of person you'd expect to be up-to-date on internet memes, a computing researcher at the University of Lancaster named Adam Lindsay. Every LOLCODE keyword is written in all caps, and they all look like they were typed by a cat who really wants a cheeseburger, but nonetheless is really polite about it. Every LOLCODE program begins with the "Hi" keyword, followed by the version of LOLCODE that you're using, and then terminates with the "K thanks, bye" keyword. LOLCODE has 6 different data types. Noob is basically just a null data type. If you declare a variable without assigning it a value, it will be noob by default. Truth is a Boolean value. You can assign to truth one of 2 values, either win or fail. Number and numbar are int and float respectively. They basically act exactly how you expect them to. Yarn is a string value, which, yeah. Yarns act mostly how they do in other languages, except for the escape sequences. While many other languages might use a backslash, LOLCODE uses a colon, which will make sense in a second. Let's go over a couple of escape sequences. A smiley face is a new line. A smiley face, but like sharp, is a tab character. Colon double quote is just a double quote character, and the double colon is just the colon character. And an open mouth emote is actually the beep character, which is an ASCII character, which I completely forgot about, but it makes a beep sound on your computer when it's printed. If you're on Windows, that's the sound of the beep character. The last data type is bucket, which is just an array data type, and a slot in a bucket can contain either a variable or a function. Some SOLang elitists say that LOLCODE isn't a real SOLang, since the only thing that's arguably strange about it is its syntax, and its behavior and semantics are really not anything out of the ordinary. But that's definitely something you can't say about our next language. BrainF is arguably the esoteric programming language. It was created in 1993 by Urban Mueller because he saw false with its 1 kilobyte compiler and said, you know what, we can go smaller, and proceeded to write a compiler that was only 240 bytes. It's actually so easy to write a parser for BrainF that an interpreter was written for it in Piet by one Matthias Luther. The BrainF language is comprised of 8 single-character commands and 1 data pointer that moves along a virtual tape. It is basically supposed to be a relatively unabstracted Turing machine. And you can technically write any possible program in it, but there's really no reason to besides some good old-fashioned fun. JS is not actually its own language. Instead, it is a valid style of programming in JavaScript. Now, while standard JavaScript doesn't look that strange, it does hide some pretty guano insane behavior. Insane behavior that JS takes advantage of to create one of the most unreadable syntaxes in existence. You see, in JavaScript, every function is an object that's an instance of the function class. This means that JavaScript can convert an internal string to a function, and because of the aforementioned insane JS behavior, it's possible to create basically any string from only these 6 characters. Let's use this example from the SOLang wiki of writing the lowercase character a. The character a is found at the second character in false, so it can be broken down into accessing false at array index 1. False can be made from adding the false bool value to an empty array, so we can throw that into some parentheses next to the array accessor. To get the false bool value, we can use the negation operator to any truthy value, such as an empty array, so we can rewrite false as not empty array. Now we need to get the number 1. 1 can be rewritten as the plus operator applied to the true boolean value, and we can get true simply by using a negation operator on the false value, which we already know how to get. We can also rewrite the function constructor as this, and we already know how to rewrite strings. Nobody really uses JS on its own, and people mostly just use one of the many JS encoders. Malbolge might actually... I need to figure out how this... Malbolge might be the most insane programming language ever invented. It was created in 1998 by Ben Olmsted and was named after the 8th circle of hell and the world's earliest example of self-insert fanfiction, Dante's Inferno. And it certainly has earned that name. If you thought BrainF was hard to program in, beware, because Malbolge takes that difficulty and cranks it up to 10,000. Malbolge is a machine language for a ternary virtual machine, which means that all the memory and values in this machine use 3 states instead of the 2 states that most modern computing machines use. The Malbolge interpreter provides a set of instructions for a program to make use of, including the crazy operation, which takes 2 ternary numbers and combines them using this table to produce a new number. After each instruction is executed, it gets encrypted, so that the next time it gets called, it'll end up doing something completely different, which makes Malbolge near impossible to program in. Malbolge is actually so difficult to program in that the first program written in it wasn't written until 2 years after its release. Even then, the program wasn't even written by a person. A guy named Andrew Cook had to create a beam search algorithm in Lisp to generate it. Even Olmsted himself has never written a program in it. And nobody really knows if loops are possible in Malbolge in any sensible way. In fact, it wasn't until 7 years after release in 2005 when Hisashi Uzawa was able to create the first 99 bottles of beer program, which is basically an equivalent of a Hello World program but using loops and conditionals. This is what a Hello World program looks like in Malbolge. Total nonsense. However, in this cat program that just takes an input from the user and then prints it back, I think I'm picking up a little bit of LOLCODE. Now, while these languages are, without a doubt, very silly, I do think they hold a genuinely important place in the field of computing. SOLangs in general, that is, not just these ones in particular. In a field that's host to an incredibly vocal, toxic minority who will relentlessly scream and cry at you for using a language or paradigm they don't like, and is increasingly being flooded with soulless garbage made purely to take advantage of other people, or to just grab a quick buck, SOLangs provide a fantastic reprieve from the norm. Each SOLang is its own work of art, taking the science and mathematics behind programming languages and imagining incredible and bizarre ways to break away from the standard. SOLangs are parody literature for the field of computer science, challenging and questioning the norm through a comedic and engaging lens. And that's what I believe makes them truly special.